Mm-hmm.
Should we hide the screen here?
If you want, you can minimize it in the top right.
Hi everyone, can you hear me?
Let's close it.
Okay, thank you. So I'm Z. Today, thank you for joining me for the shadow study presentation. I do this presentation mainly because our project is in Boston. That has a very clear regulation. So any new shadow can only last 2 hours on this Copley square. So you could see this gray color is the old shadow cast by the surrounding buildings. So this is our site, and we put it in color. So if our building's shadow like happens in this location, that means we cast new shadow. If just within this green boundary, so it means we are not cast new shadow. So before that, we mainly use Rhino render to test how to satisfy the requirement, but it's pretty slow. We have to render the old one and the new one, and then to calculate from what time to what time. So later we begin to think, is there a way to make it more efficient? There has several difficulties. The first one is this Copley square is not a flat surface. It's with a little bit landscape, so it's a little mesh here. So it gives us more complicated to do that. Another thing is we need to compare the new shadow and the old shadow in a very accurate way, refers to the 2-hour limitation. The third point is how to use the graphic way to help other people understand how we calculate. So after we get the result, we use the human UI to show this graphic way to show how it works. So the logic is I calculate the area of the old shadows area, and then calculate the new shadows area, and then compare them. Like use the new one, subtract the old one. If the results are 0, that means we are not cast a new shadow at this moment. If it's bigger than 0, it means we cast more shadow. So this diagram shows very clearly what time period we cast a new shadow and at what time it has the maximum amount. So it's more clear. And also later we may think about a way to limitate the volume's shape, because every time I have to start the calculation, it's like it's really slow. It needs like 5 to 10 minutes to calculate. So later we think, could we think of boundary to limitate our volume, so it will give us very quick way to think about how to eliminate. So this is the basic stuff I will cover today. So then I will jump to the Rhino file. So I already simplify our Rhino file. First, we need use some vector to get the sound vector. I still use Ladybug. I know our rich group already have some Python for the sound vector, but I'm not very good at it. So right now I think it works for me. So I also remember we have basic tutorials for the Ladybug, so I will just go through very quickly for this part. First, we use the weather file. Open the weather file, this component, and connect with the import EPW, and then we connect with the toggle. You choose true. It will pump up a dialog. You will then you choose the EPW file you download. So then we get our location, then use the sun path. So you could see here, use the sun path to get our sun vector. So basically this progress, and I use the analyze period here. So basically I choose October 21st, because before we need to simplify all the progress. So from the rendering analyzed, we already know from 10 a.m. to 1 p.m. it will influence the shadow. So we just narrow down these 3 hours, because I use 9 and 12 because that has the daylight saving here. So you need to be very careful what the number is here, because some months you need to subtract 1 to get the right vector here. So because it's 2-hour elimination, so I separate them in 60, so it's very accurate. It's accurate to minute. Then we get our, you can see we get our the sun vector here. And also sometimes you need to check very specific what's the hour, what's the minute. So you could use this item here to help you to analyze sometimes. So after we get our sun vector here, so I built, this is our project's volume basically. So I use Grasshopper to build these 2 stack together, because only these 2 influence the shadows here. So we get our volume here. I will not go through this script because we have our own logic of how to build this volume.
Isaiah, this is Rob in New Haven. Is it possible for you to highlight, to go back 1 step and just click on the sun vectors and highlight them? Will they display?
You mean to highlight what?
Click on the vector.
The sun vectors.
Oh, if I click on the sun, it's really slow. It's weird.
Okay.
Yeah, okay. Because it's calculated 180 times. So maybe we can try later. I have some simple file on the.
Okay, that's fine.
Okay, yeah. So I will go through all the script for our own project. Then I will subtract some useful point, maybe for other projects. Yeah. Okay. So we get our own volume here, and because only these 2 buildings influenced by our building, so I just choose 1 and 2, and I only use the ladybug to get the sun vector, and later I just get rid of all the shadows from ladybug, because sometimes it's really to get bugs. So first I use, this is from Rhino mesh shadow. So it works really well on the flat surface. So this is our volume mesh here, and this is the light, and I use the default. So you could see we get this shadow is a curve on here, and then how to get the shadow on this coupling square. The logic is we extrude this curve from in the sun vector way. Then this volume, they will overlap with this surface. Then we get this surface. Yeah, this is overlay part. So then we get our surface basically. So you see, it's not a flat one, so it works really well here. So I think people could use this component to get their shadow on some free surface here. So we also get our 2 buildings shadow on this coupling square. So I reunion them. So this one I renew 3 of them. This means the new shadow, the whole shadow, right? And this is the and this is the old one. So as I explained, so my logic is to compare these 2 areas of shadows. If it becomes larger, it definitely means we cast more shadow, right? If it's just like 0, means they are equal. So after we get the correct shadow surface, then we need to compare them. So we get the area, because we need to careful, because sometimes the shadow, even we reunion them, sometimes they're separate from each other. So we need to use the mask addition. It will automatically like this have two surfaces. They will add the area for these two items. So then we get the two numbers from the new shadow and the old one. There also have a tricky stuff here. So even the number is exactly the same sometimes, but they are from different resources. Sometimes Grasshopper cannot recognize they are the same because they are from different resources. So you could see the number, they have 5.6, so it's maybe too accurate. We need to make it like less accurate. So we use this way just to make it only 4 decimal here. So then it works really well. So we use this equal stuff to compile them. So we choose this here. If that means true, it means they are not equal. It means they become larger. We cast a new shadow. It means false means they are equal, so they are not cast a new shadow. So right now we need to calculate how many false here, how many truths here. So basically, I just transfer the false to 0, true to 1. So basically, we have 0, we have 61, 1, we have 119. So because 2-hour elimination is like 120 minutes, so right now we are good. We are within the limitation. We are satisfied the requirement. So this basic is the logic how we satisfy the requirement in Boston. But later, because it's hard for people to understand, so we use the human UI to see how to make it work. So it's very simple. It's just like to subtract, you use the new one to subtract the old one, to make it larger, to divide by the old one. Then we get our data. This is this human UI, so you could see I just show here. So basically, you could see in these 3 hours, this period, they pump out, that means they cast a new shadow. So it's very clear what time and what time is maximum. So I think this is a good way to show that, basically. So after that, as I mentioned, I still feel a little way too long to get each calculation, because every time we change the value, I need to calculate again. So right now I'm kind of thinking, could we make some boundary to limit our value here? So I began to do some research about this is from Ladybug, but it's not good. Sometimes it's not work really well. So this this component means to illustrate the value that can build with this to make sure the new development does not shade the surrounding property. That means so if we have park here, we don't want our building to influence the park. It will works really well, but you need to transfer some part, because we have 2-hour elimination, not just to influence the Copley square, right? So basically my logic here is, so I choose the equal stuff. The equal stuff means that they are satisfied the requirement. They are not cast a new shadow, right? Basically, I get the true, false, and I select them. This basically, like I select them and extrude them with this surface. So this curves means it means you can imagine these are like parks. We don't want the building influence the shadow within these parks. So I put this curve into object curves, and just very simple this like surface area for our value here. Then we get the surface. So if our building just like not beyond like the how to say that, the points, the lowest points. So here is my way. I just like extrude extrude this surface and then like a solid difference, and then we get so this is a little here. So I extrude this surface in this way and then build a volume here and then use the solid difference. Then we get the lowest point, the surface here. So this could help us like limit our boundary. But later I found this is really is not good enough. Then I get rid of the solar envelope. I use my own components to do the regulation, and it's more accurate because this accuracy depends on the. You could see there are some grids here. Depends on the size of the grid. Sometimes it's really slow. So I will introduce that a little bit, but yeah. No, I cannot. Because it's freezing here. Do you have any question right now?
Check the chat.
Okay. Okay.
Say, I have a question.
Yeah, sure.
Is the concept of what you're doing is you're actually projecting the surface back towards the sun vectors and creating a tent under which you can shape the building?
Yes. What I did is something like that. Yeah.
Okay. So what's in green on what's highlighted in green on your screen, is that a number of projections that have to be sort of welded together into one single mesh?
Yes.
Okay.
Yeah.
And is that, sorry, just to clarify, I apologize, I came in a little late, but the projections that are showing on this, is that for a certain date range then the one that you were showing earlier with the graph?
Yes. So
you can go to the PDF.
The reason why you ask is that we did an exercise like this for Milan just to establish a zoning envelope. They have a 60-degree rule. So we created a kind of tent shape under which we could build.
Yeah.
But we are now working on a project in Vancouver which has a similar daylighting shadow restriction. And what we found sort of impossible to figure out was how to do more than just one moment and sort of weld those into a mesh that is, represents a time range.
Exactly.
And that seems like what you've done here.
Yeah, it's not one moment. So first I get you see I choose the I get the curves, right? I just choose them, and this curves has its own time vector. So it's not the same moment. It's from different moment. This moment are the true one. It means they are not cast a new shadow. So it's not the one moment. It's several moments that satisfy the restriction. So then, yeah.
Is it a total annual analysis? It's like every day, every hour, daylight hour of the year that you're doing?
No, I just like specific 3 hours on October 21st. Because
so it's a specific day.
Yeah, it depends on what accurate you need to, because we need to accurate to minute. If you only need to accurate to hours, I think it also works well, because we need to calculate 118 times here. So
No, ours is the same way. We're gonna have to calculate real tight, like 5-minute intervals or something like that. And so this is super helpful to see, because you guys are doing the exact same exercise that we're going to need to do for our Vancouver project.
Yeah.
I had a quick question about the chart that you're showing currently.
Yeah.
This might be a really dumb question, but those are showing all the days of the year and how much shadow is occurring with the older scheme on the park. I just wanted to clarify that. Is that what it's showing?
Oh, it only shows on October 21st from 10 a.m. to 1 p.m. because this is a worst situation for our project. So yeah. we just focus on these 3 hours. Yeah.
Understood.
Yeah.
Okay.
Yeah. If these 3 hours satisfy the restriction, it will definitely satisfy the other time, right?
Right.
Yeah. I think it works. Yeah. So basically, we extrude and then use.
Click it.
Oh, I will not click on that.
Okay.
Yeah. So basically, I already saved some shape here, so we could look at. So basically, finally, I get this volume. If our building with it, it works really well. But later, I just feel this is not very accurate and it's also really slow. So I'm using my own stuff. Basically, the logic is very simple. Yeah, basically just the same. We get the correct moment with the correct sound vector. Then we extrude in the correct way. Then we get this volume here, and then just use some solid. Oh, that has small piece here, but you see this the piece. But this is much quicker, and also it not depends on the grid what we create here. So I like this one better. Oops, I can show you on my
It makes more sense that way too, because it's like it's in your building, not the context.
Yes. So you could see. Sorry, I click on. So the blue one is the later. I use my own components, and this red one is from the ladybug. You see, they're mostly the same, especially this part. This part is not the same because we use extrude, right? So they are cut. So the blue one is more accurate, but almost the same. You could see. So a little bit pump out, but yeah. So it shows also very fine. I think the two-way also very correct. So
okay.
So basically, this is the I think basically this is what I did for my our back base station project in Boston. So I think even it's very specific to practical issues, we still have some points useful for other projects. So like if your if your surface is not a flat one, you could use our this component to get the. Oh, sorry, it's this one. You see, we want to cast shadow on this strange surface. We still can get the right shadow. So this is the first point. I think may be useful for other projects. And since I already tested many times, right now it works well. I think so. There are some issue with the ladybug its own shadow analyze. Sometimes it's hard to work on the strange surface, and sometimes it's just to get the mesh. It's not a surface. I don't know why, but yeah. Later, I think the sound envelope and sound fan is really useful. So I think most people know, but I want to explain some relationship between these different components. So this one, you could see it works like illustrate the volume that should be clear of shading in order to provide solar access to test surface for a given set of sound vectors. So it means if we don't want to influence the park here, our building should not like go inside this green volume, right? So this is some fun. For the sound envelope, so as I mentioned, I think we talked this before. So this is just illustrate the volume that could build in this volume not to influence other part. So you could see we get this surface is if our building within this surface, it will not influence the park. So these two, the difference, the biggest point, you need to choose the right base surface and the right object curves. So, but you could find very interesting stuff. This surface here actually is the same as this one. right? Actually, they should match together. So these two components depends how you use it. So sometimes it could work on each way. And yeah, this is by my own components. You see the same result. So I put these three here. So later we could use each way. So it could transfer to each of them. So I think it's very funny. We also could use the script I did for my project. We could use a shadow comparison. So this is our volume, and you could put the text together. I think it's fine. You don't need to separate them, and you get finally you get your shadow on this surface, this one. And the reunion, this works well. I don't know why it turns orange, but it's fine. Then we calculate the area. It's the same logic. Yeah, I will just very quick. So it works well, and then we get our calculation here. Then we can see the charts here. Yeah. So yeah, I think basically that's all I will show today. So yeah, just half an hour. Okay, thank you.
Thanks, Ed. That was great.
Yeah, thanks a lot. This is super helpful.
Yeah, sure. Okay. Thank you.
If anybody's on the line that hasn't used Ladybug or Honeybee, it's a kind of multi-part installation. It's a little bit tricky. So rather than try and do it yourself and mess it up the way I did about 4 or 5 times, I suggest you go to somebody at either New Haven or New York who knows how to do it. Jay obviously has done it. I've done it here, and I know Chad has done it here in New Haven. There's no use torturing yourself because there's a lot of underlying software that it's not just Ladybug and Honeybee. They refer to several other pieces of software that need to be installed. Thank you, Jay.
Thank you. Thank you.
Bye.
Bye.